Hi viewers, I am glad to welcome you all to our Vidhyalakshmi Matriculation Higher Secondary School. I am Stalin, PG Assistant in Chemistry. Today, we are going to discuss about Plus 2 Chemistry, lesson number 8, Ionic Equilibrium. Fine, shall we? What do you see in the picture? See grapes, lemon, curd, tamarind and tomato. Yes. So what is the taste of this picture? Yes, you are absolutely correct. Sour in taste. Why it has a sour in taste? In Latin word, acidus, which means sour. So the term acids coming from the Latin word acidus. So this things having the acid. That's why it has the sour in taste. For example, grapes having tartaric acids, lemons having citric acid, and oxalic acid present in the tomato, and lactic acid present in curd. Okay. Now we are discussed about what are the concept of acid and bases. First of all, what are the characteristics of acid and bases? See, acids which turns blue litmus into red, whereas base which turns a red litmus into blue. Okay, acids having sour in taste, whereas bases having bitter in taste. Then acids are corrosive in nature, bases are slippery in nature. This is not sufficient to describe about the acids and bases. That's why we need a new concept to describe acid and bases. Okay, so that a new concept is introduced by Mr. Swedish chemist Sandy Arrhenius. See, according to Arrhenius concept, acids are the substances which gives H plus ion in water. Acids, what is acids? Acids are the substances which gives H plus ion in water. Okay, acids are dissociated to give you H plus ion, that is proton in water. For example, HCl, which dissociated in water, which gives H plus and Cl minus ion. Similarly, sulfuric acids dissociated in water, which gives 2H plus and SO4 2 minus ion. So both compounds produces H plus ion, so that there are belongings to acids. Similarly, here listen, here H plus ion, which is highly hydrated with water, so that it always exists as a H3O plus ion. H plus combined with water, which form a H3O plus ion. So we use both H plus and H3O plus to mean the same. What about bases? Bases are the substances which gives hydroxyl ion in water. So substances gives hydroxyl ion in water. They are called as bases. Let us take sodium hydroxide, which is dissociated in water, which form a Na plus and OH minus. Similarly, calcium hydroxide dissociated in water, which gives calcium 2 plus ion and 2 OH minus ion. Here, these substances gives OH minus ion in water, so that there are belong to bases. Okay, viewers, fine. See how to classify the following based on Arrhenius theory. See the first one, phosphoric acids, which produces 3H plus ion. So here which produces H plus ion, so it belongs to acid. Next one, acetic acid, which is dissociated into acetate and H plus ion. This is also produces H plus ion, so it is also belongs to acid. What about third one, barium hydroxide, dissociated in water to form a barium 2 plus ion and 2 OH minus ion. Here barium hydroxide produces OH minus ion, so it belongs to bases. You are absolutely correct. You got it. Okay, next one, aluminum hydroxide. So aluminum hydroxide dissociated in water, which produces aluminum 3 plus and 3 OH minus ion. Clear? Right? So, it is also belongs to bases. So, this theory is not applicable in all the time, in all the substances. It has some limitation. So, in the absence of water or in the presence of non-aqueous solution, solvents, it does not explain about the acid and bases fully. So, it is the main important limitation of Arrhenius theory. For example, non-aqueous solvents like ether, benzene, acetone, THF, etc. It does not fail to explain whether it is acid or bases. Okay, and also ammonia. Ammonia does not give any hydrogen ion. It does not give any OH minus ion, but it is a base. Okay, so the acidity of ammonia is not explained by Arrhenius theory. That is the main limitation of Arrhenius theory. One is, it does not explain in the presence of non-aqueous solvents. Okay, and it does not explain the basic nature of ammonia. That is the main limitation of Arrhenius concept. So that we need a new concept. Okay, that is Lowry-Brønsted theory. Okay, according to Lowry-Brønsted theory, acids are the substances which gives proton. Here we cannot use water. Okay, so acids which gives proton. So proton donors are called acids. What about bases? Bases are nothing but proton acceptors which accept the proton. So acids are gives proton, bases are accept proton. So, let us assume hydrochloric acid. Here hydrochloric acid is dissolved in water which produces H3O plus and Cl minus ion. See here hydrogen donate proton to the water molecule. Okay, so which form H3O plus and Cl minus. So HCl donate proton to water, so that HCl acts as the acid. Okay. Next, water. Water accept the proton. Water accept the proton. So it is considered as a base. So according to Lowry-Brønsted theory, acids are proton donor. Here hydrochloric acids donate proton to the water molecule, whereas water molecule accept the proton from the HCl. So hydrochloric acid acts as a acid, Lewis acid. Water acts as a Lewis base because which accept proton. Clear, students? Okay. Next one is, let us take ammonia. So ammonia is a base in general. Here ammonia, listen, ammonia dissolve in water to form a ammonium ion and OH minus ion. So ammonia accept one proton become ammonium. Ammonia accept one proton become a ammonia. So ammonia accept a proton. So it belongs to bases. Water, here water donate proton. Here water acts as a acid. In the previous one, water acts as a base, whereas in the presence of ammonia, it acts as a acid. So water having a double character. Sometimes it acts as a acid, some other times it acts as a base. So it has a dual character. Clear? Let us take hydrochloric acid, dissolve in water, which produces H3O plus and Cl minus ion. Already I told HCl is a proton donor, water is a proton acceptor, and here in the reverse process, here see the equilibrium symbol is there, which means both forward and backward reaction is taking place. Okay, here in backward reaction, H3O plus gives a H plus ion to the Cl minus ion. So H3O plus is a proton donor, Cl minus is a proton acceptor. So in the forward reaction, hydrochloric acid, H2O is a base, H3O plus in the reverse reaction, H3O plus is a acid, whereas here Cl minus is a base. See, next let us take ammonia. In ammonia, which accept proton, water which gives proton. In the reverse reaction, ammonia proton donor. OH minus is a proton acceptor. So, what are the limitations of Lowry-Brønsted theory? It fulfills some aspects about acid and base, but it also having a limitation. In the absence of hydrogen, only it is applicable for in the presence of hydrogen. So, in the absence of hydrogen, we couldn't explain about the acid and bases. See, it failed to explain that the molecules do not donate protons, such as boron, trifluoride and aluminum chloride. So, it failed to explain that the molecules do not containing or do not donate proton. Okay, that is the important limitation of Lowry-Brønsted theory. So, that limitation is overcome by the new concept, that is electronic concept, that is called Lewis theory. So, G and Lewis proposed a theory about the acid and bases. So, we know everything made up of atoms. Atom consists of electron, proton and neutrons. Okay, so most of all the elements are atoms containing electrons. So, based on the electron, he tried to explain, he tried to describe about the acid and bases. So, according to Lewis concept, acids are the substances electron acceptor, which accept electrons. So, electron acceptors are called acid. What about bases? Electron donors. So, bases are electron donors. Okay. So, what is Lewis acid? What is the nature of Lewis acid? In general, positive ions are considered as a Lewis acid. Why the positive ions are considered as a Lewis acid? Because which are electron deficient. So, Lewis acids are nothing but positive ion or electron deficient molecules are considered as a Lewis acid. Then Lewis base. So, Lewis bases are nothing but negative charged molecules or ions, negative charged ions, because which containing excess of electron rich molecules. So, electron rich molecules are considered as a Lewis base. So, let us take an example. Here boron trifluoride reacted with ammonia which form a coordinate compound. Okay. Here what is the atomic number of boron? 5. Very good. Atomic number of boron is 5. That means it has 3 valency electron. It has 3 electron in the valence shell. Okay. So, that 3 electron bonded with the fluorine, covalently bonded with the fluorine, which form a boron trifluoride. Even though it form a bonding with the fluorine, it is electron deficient. It does not acquire a octet structure. Why bonding taking place? To acquire a octet structure. So, those molecules having a octet structure, they are highly stable. For that only the molecules or atoms or ions undergo chemical reaction. Okay, clear? Right. Here after the bonding boron with the fluorine, still it has a electron deficient. It needs 2 more electron. Okay. So, boron having 2 more electron to get the octet structure. Whereas ammonia, what is the atomic number of ammonia? Sorry, what is the atomic number of nitrogen? 7. So, it has how many valence electron in the outermost shell? 5 electrons. Among the 5 electron, 3 electrons are covalently bonded with the hydrogen. 3 electrons are covalently bonded with the hydrogen. So, it has 2 non-bonded electron. Okay. So, nitrogen having 2 non-bonded electron, that is lone pair electron. That lone pair electrons are given to boron trifluoride. I am already told boron having 6 electron in the outermost shell. It needs 2 more electron to get the octet structure. That 2 more electron are given by ammonia. So, which form a coordinate covalent bond. See the structure here, the 2 electrons are transferred from nitrogen to boron to fulfill the octet structure of boron. Okay. So, here ammonia donate electron. Boron trifluoride accept electron. So, ammonia is a Lewis base. So, according to Lewis concept, Ammonia is a Lewis base because which donate electron, whereas boron trifluoride is a electron acceptor, which is the electron deficient molecule, so which is called as Lewis acid. Clear? So then, what are the differences between Lewis acid and Lewis base? I am already told. Lewis acids are electron deficient. For example, boron trifluoride, aluminum chloride are example for electron deficient molecules. And what about Lewis base? Electron rich molecules are called Lewis base. So ammonia already having one lone pair electron, and water which is also having two lone pair electrons. So there are electron rich species, there are belongs to Lewis base. Then all metal ion. So what is metal? Metals are nothing but electropositive elements. Okay, already it is a electron deficient one. So that it belongs to Lewis acid. So iron, copper, chromium, okay, these ions are considered as a Lewis acid. Then negative ions, fluoride ion, chloride ion, sulfate radicals, all these species having a negative charge on it, so that it belongs to Lewis bases. Then in Lewis acids which containing multiple bonds. Here carbon dioxide which containing C double bond O, double bond O. I mean O. What is the structure of carbon dioxide? O. O, C, double bond O. So this is the structure of carbon dioxide. See here the oxygen and carbon having multiple bonds. Okay, so if the compounds having multiple bonds, they behaves like a Lewis acids. Whereas in a Lewis base, see ethylene and acetylene is there. Okay, so ethylene and acetylene, here carbon having a multiple bond. So if the species having carbon multiple bond, they are considered as a Lewis bases. The molecules having, listen, like a carbon dioxide, sulfur dioxides having a multiple bonds, they are considered as a Lewis acid. Then carbonium ion. Okay, what is carbonium ion? Carbonium ion is nothing but the carbon having a positive charge. Carbocations are nothing but carbonium ion. So carbonium ions are considered as a Lewis acid. Carbanion, here carbon having a negative charges on it, so which is considered as a Lewis base. See, identify the acid and base pair. Here in calcium oxide reacted with carbon dioxide which form a calcium carbide. So in calcium oxide and carbon dioxide, which is acid, which one is base? Okay, so let us take calcium oxide reacted with calcium oxide reacted with carbon dioxide which form a calcium carbonate. Okay, so here carbon dioxide is having, already I told, carbon multiple bonds. So if the species having multiple bonds which belongs to acids. So here carbon dioxide is a acid, calcium oxide is a base. So calcium oxide is a Lewis base. Okay, carbon dioxide is a Lewis acid. Clear? So let us take a next example. So here this is dimethyl ether. This one is aluminum chloride. Here dimethyl ether having, so oxygen having two lone pair electron. Okay, so here dimethyl ether having excess of electron, more electron denser molecules, so that it donate pair of electron to the aluminum chloride. Here aluminum chloride is the electron deficient molecules, so which form a coordinate covalent bond. So diethyl ether form a coordinate covalent bond with aluminum chloride. So here dimethyl ether gives electron to aluminum chloride. So dimethyl ether act as a Lewis base. Okay, aluminum chloride accept electron, so which belongs to Lewis acids. Clear? I hope you are understood about the concept of acid and bases. Next one. See here, boric acid H3BO3 treated with or dissolved with water, which form a BHO4 minus and H plus. Okay, predict the nature of boric acids using Lewis concept. See here, boric acid H3BO3 treated with water. What is the formula for water? HOH. Let us write water in HOH. Okay. So, the OH molecules are combined with H3BO3, which form BOH4 minus. See, here OH attracted by H3BO3 and